Hi, everybody. So one of the assignments this week are with a probability review. And if you look on Canvas, I posted a couple of videos. One video was introducing just the basic concepts of probability. And then the other video is talking about contingency tables, which you saw both of those types of questions on the worksheet. But I'm still getting a few questions on, I believe it's problem 1, which is a little bit more complicated probability problem because you're combining multiple events or compound events together. So if you're looking at the screen here, this is very, very similar to the worksheet problem 1, but I threw in some different numbers. Okay, so since we're just kind of introducing ourselves to probability, I wanted to make it fairly straightforward here. So this is going to line up fairly straightforwardly with the worksheet, but just realize the numbers are different. You're going to have to redo the problem with the numbers that you have. Okay, now in statistics, we are going to be covering probability fairly soon. And probability tends to be a subject that people struggle with in statistics. So we're trying to introduce it to you a little bit early here in the co-rec class so that you're kind of a step ahead the rest of the stats students that you're with. Okay, so we're looking at this, and we see insulin pens have a malfunction rate of 12%. Okay, in this version of the problem, I'm saying malfunction rate of 12%. And just thinking about what this means, if you have a box of 200 pens, 24 of them are defective in some way. Okay, so part A says find the probability of randomly selecting 3 pens in a row from a brand new box, and after each pen, you're immediately throwing it away because it's defective. Okay, so a couple things I want to point out. You have a box of 200 pens. What's happening here is they want to find out the probability of drawing a pen, it being defective and you throwing it away, drawing another pen from the box of 199 now, that being defective, throwing it away, and then drawing another pen out of the box of 198 now and throwing that away. Okay, so when you look at probability, there are 2 rules. There's the and formula and the or formula. Okay, now in this case, when I'm looking at it, I'm thinking or asking myself, do I want to find the probability of a defective first pen and a defective second pen and a defective third pen? So do I want those ands in there? Or the other option is, do I want a defective pen or a defective pen or a defective pen? The key here is that it says we want all 3 to be defective. So that means I want to find the probability of the first pen being defective and the second being defective and the third being defective. Okay, so a big part of probability questions is trying to decipher or translate, is it an and situation like this one is, or an or situation? Okay, and then basic idea with probability formulas, and means you're going to separate these by multiplication and have 3 mini problems. And if it was an or, you were separating them by addition. And I'm simplifying things a little bit there, but for this problem, that holds true. Okay, so the first part of this is find the probability of just this guy times the probability of this guy times the probability of this guy. Okay, keeping in mind that we are immediately discarding after each time. Okay, so what's the probability of drawing a pen from a new box of 200 pens and one of them, this first one, being defective? Okay, so let me say that again. What's the probability of drawing a pen and the first one being defective? Okay, well, how many defective pens are there? We know from up here in the problem, 24 of them are defective. So the probability of drawing a defective pen would be 24 out of 200. So far, so good? Okay, times. Let's suppose that the first pen was defective and you've taken it out and you've thrown that one defective pen away. Okay, Now I want to know, find the probability of drawing a second pen and it too being defective. Okay, now here's the key. You don't have 200 pens anymore. You threw one away. So you only have 199. And you no longer have 24 defective pens because you took one and threw it away. So you only have 23 defective pens. So the probability of pulling a second defective pen is actually 23 out of 199. So let's think about that for a second. I used 199 in the bottom because I did have 200, but I threw one away because it was defective. And I did have 24 pens that were defective, but now I only have 23. Okay, and again, this fraction here came from this probability here. And our third question is find the probability of a defective pen. After you've already drawn out one, threw it away, drawn out another, and threw it away. Okay, so think about that for a second. I always like to do the denominator first. So, okay, I started with 200 pens. I have now taken 2 out and thrown them away. So that means the remainder that I have left is I only have 198 pens. So that will go in the bottom. And I started with 24 defective pens, but now I've thrown 2 away. So now I only have 22 defective pens. Okay, so take a second and kind of absorb that, how we set that up. Okay, and now in your calculator, you're going to do 24 divided by 200 times 23 divided by 199 times 22 divided by 198. And when I put that in my calculator, I'm going to double check that I put it in correctly. That's looking good. I'm seeing 0.0015. I'm going to round that to 4 decimal places. But whatever the directions say in your assignment, make sure you round accordingly. Okay? So far, so good? Now, part B is going to be very, very, very similar. The only thing is, instead of looking at defective pens, now we are going to be looking at effective pens, the good ones, the ones that are not an issue. So, I want to find the probability of the first pen being effective and the second pen being effective and the third pen being effective. Okay, so same story as before. I had to think about, is this an and situation or an or situation? Okay, but keep in mind, I'm trying to find the probability of 3 effective pens in a row. That means the first one's good, and the second one's good, and the third one's good. It's not good enough to be an or situation where, okay, as long as one of them is effective, then I'm good. No, no, no. All 3 must be effective. Okay? So I'm not going to do this whole problem because I don't want to give it completely away. But if we're looking at this, instead of looking at, for the first effective pen, instead of looking at the 24 bad pens, I'm now going to look at the good pens, the effective pens. So if I had a box of 200, okay, we're no longer in the first scenario. Throw this story out. So we're starting with that brand new box, 200 pens. 24 of them are defective. So if I do 200 minus 24, I'm getting 176. So what's the probability of the first pen being effective? Well, I have 176 good ones out of 200. That's because I had 24 bad ones. So far, so good? All right. Now I need to find the probability of the second pen being effective. Keeping in mind, I've already pulled out an effective pen and I used it and threw it away. So the first one's, it was a good pen and it's gone now. Okay. So I had 176 pens, but I used one. It's gone. So now I have 175 pens. Good pens. So far, so good? Divided by, I started with a box of 200, but I pulled a pen, a good pen, I used it, I threw it away. Now I only have 199 pens in total left. Okay, look at those numbers, make sure you see where I'm getting them from. And then our third piece of this one is find the probability of a third pen being effective, assuming that you've pulled a good one, used it, threw it away, pulled another good one, used it, and threw it away. So now I want to find the probability of pulling another good one. Well, I had 176 good, used one, got down to 175. Now I used another one, now I should be down to 174. Okay, and I started with 200 total pens. Used one, I got down to 199. Used another one, now my total should be 198. Okay, again, take a second, look at those numbers, make sure you see where I'm pulling them from. If you do have questions about why I used what number, please just let me know, send me an email. And I just typed all of those in, and I am getting 0.6801. 0.6801. Okay, so hopefully that gives you some guidance for the worksheet for this week for probability. Again, I know we're kind of throwing you in with probability. Make sure you watch those videos that I posted. It'll very much help in statistics when we get to probability that you've had a head start, because again, it tends to be a tricky subject for people. Okay, good luck.